All right, section 7.4. We're getting back to that proportional stuff and ratios and all that kind of thing. So it's just a couple more different ratios you have to remember. These are really not that difficult if you can just remember what you compare to what. That's the hardest part about doing this. All right, so here's our problem. We have a triangle, and look at this. See this one side right here? You've got a side inside that big triangle that's parallel to one of the other sides. So what we're going to do right here only works when you have one of these sides parallel to another side. Everybody see that? So I've marked the sides being parallel to each other. If you look at it, those sides break off some segments to the big triangle. You've got this segment right here, from here to here, and let's do it in a different color. We'll call that A. So A represents from here all the way to this point. Everybody see that? All right, then this little tiny segment right here I'll call B. I'll call this one C, and I'll call this one D. We're not even going to talk about the triangles being similar and all that kind of stuff. I guess you could. In order to prove what I'm going to show you, you probably go through a thing where you have similar triangles and you do some ratios and proportions and all that. But I'm not going to go through that whole thing. I'm just going to show you what the ratios are, what the proportion is. It's really not that hard at all. So this theorem, we're going to deal with a couple different theorems. A theorem, I can't spell. Let's do this. T-H-E-R-E-M. Why did I put an A in there? I don't know why. Anyway, you have a theorem, and sometimes they name the theorem, sometimes they don't. Sometimes they put numbers. I've known some geometry teachers that, like, I don't know, this theorem is theorem 7.5. Okay, and I know that there's some geometry teachers out there that will have you on a test or a quiz make you write out word for word if they'll say, okay, what does theorem 7.5 say? And you got to write out word for word. I mean, that's ridiculous. I think that's stupid. Because not every book is this theorem names theorem 7.5. Because this just happens to be, what, chapter 7, and it's our fifth theorem. Okay, it doesn't even have anything to do with what section we're in. So that's why they call it theorem 7.5. So I don't have you memorize these things. And again, old school geometry teachers would probably have you do that and memorize them word for word and have quizzes and tests where you have to, write out the names of the theorems and what they say and all that kind of stuff. Really, I just think that's nonsense. What we want to do is we want to look at the practical use of this theorem. I want you to know how to use this particular theorem. Oh, they even give it a name too. They call it the triangle proportionality theorem. Okay, big deal. So you might memorize that one day for the test and you'll forget it the rest of your life. But you should know how to use it. Let's see. I want to make a comparison. When you have a situation like this, these segments, A and B, C and D, those segments are in proportion, which means how do we set them? How do we set the ratios equal to each other? Well, I can make some comparisons. I can compare A to B. All right, so if I compare A to B, I've got to compare these the same exact way. So if I go from this, I don't know, this longer segment to the little short one right here, then what am I going to do over here? Go from this segment to this one right here. So what would that be? C to D. Not CD, C to D. C-T-O-T to D. Everybody got it? There's another way you could set this up too. You can compare A to B and C to D. You could also compare A to C if you wanted to. Let's do that right here. But if you compared A to C, what do you think the other one would have to be?
B to D.
B to D. Right? Don't look at this and say, well, we just flipped it and all that kind of stuff. Just look at the triangle. If I took A, I can compare it to B. But this one has to be compared in the same way. Do you see it? So if I compare A to B, look over here. See how C is across from A? Well, it's got to be compared to that one right there. Everybody see that? Now you could go the other way. You could compare B to A if you wanted to. But if I went B to A, what would I have to do over here? D to what? To C. You see it? B to A. So if I went from that little one on the same side, if I went from the little one to the bigger one, then I would go from this little one to the bigger one on that same side. Does it make sense? It's pretty easy. Now, what's the use of this stuff? What do you think they're going to do in a problem here?
Plug each other.
What do you think they're going to do in this problem right here? Yeah, you're going to stick in some numbers. Exactly right. They're going to, they'll make C some number, D be a number, and B be a number, okay? And then they're going to ask you to solve for A. And it's pretty easy. Just set up one of these ratios or one of these proportions and then just solve for whatever's missing. How would you solve for what's missing? What would you use? Cross multiply. That's right. Let's do this just to make sure that this and this are the same thing. I just want to show you this. If we were to cross multiply, we would get what? AD equals, cross multiply this way, we would get BC. Now, if you wanted to figure out how to compare these things, that cross multiply should all come down to the same thing. They should all have the same scale factor. That's basically our scale factor. So what if we cross multiplied here? If I cross multiply here, we should get the same thing, AD equals BC. If we didn't, then our way that we're comparing our ratios are not correct. So what if I cross multiplied here? What do I get? I get AD equals BC again. Look at that. So they're both the same thing, so I can compare them just like that, all right? Let's do this, though. What if I tried to compare it a different... I tell you what, let's do one of the ways that we talked about before. I could go A to B equals C to D, or I could go the other way, which is what? B to A equals D to C. Not DC, D to C, all right? Let's see. If I cross multiply, do I get the same thing as I get down here? Yeah. Look, cross multiply there, that's BC. Cross multiply here, AD. Is that the same thing as this? Yeah, it is. Okay, so that's perfectly fine. Okay, so I can compare that way. What's another way to compare? I went A to C on this one. A to C equals B to D. Or I could go what?
C to A.
I could go C to A. So let's try it. C to A. If I go C to A, what am I going to have to do over here? D to B. Make sense? Let's cross multiply. AD equals BC. Look at that. It all cross multiplies to be the exact same thing. So does it matter which way you set up your proportions? It doesn't make any difference. Let's do away. Let's do this in a different color just to show you that it's different. Let's do it away where it doesn't work. I almost hate doing this because some people will remember that more than remember what the right way to do it is. But let's do it a wrong way. Let's go like this. Some people might say, oh, A to C equals D to B. This is the wrong way to do it. All right, so I'm going to even put it on here. That's wrong. I want to show you why it's wrong. Look, can I go A to C equals D to B? Look, I went from the top to the bottom, and then I went from the bottom to the top. Let's cross multiply and see if I get the same stuff as I got here. Okay, that's AB, and that's what? CD. Is that the same as this? No, it's not, is it? Okay, so that is wrong. You cannot compare it like that. If I go A to C, I have to go what? B to D. You see, it's just a little pattern. That's all we're doing here. If I go top to bottom, I got to go top to bottom. Or I could go, let's stop talking, just listen, please. If I go bottom to top, then I'd have to go what? Bottom to top. You see that? Okay. If I go left to right, down here I got to go what? Left to right. Okay. What about this one? Can I go A to D? So if I went A to D, what do you think the other way might be?
B to
Like
C.
B to C or C to B. Let's go B to C. Could you do it that way?
Yeah.
No, because look, that's AC, and that's what? That's BD. That's not the same thing, is it? That's wrong. So you can't do it diagonally like that. So I almost hate to even say any of that because just put something else in your head that shouldn't be there, okay? All right, so anyway, there you go. So you can't do that. All the stuff in the pink or purple, whatever color that is, you can do that fine. All right, we good? All right, enough of that. Let's go let's actually do an example, and then we'll go ahead and move on. All right, here's our triangle, and what they're going to give you some stuff. They're going to say that PT equals 7.5. So I'm just going to list them, and then we'll put them on the triangle. It says TQ is 3, and then it says SR is 2.5. SR is 2.5, and we're trying to find PS equals, and I'll put a question mark. Okay. So let's put those numbers in here. PT is 7.5. So PT from right there to right there is 7.5. TQ, this little bit right here, is 3. So we put a 3 right on the triangle. SR is 2.5. This little bit right here is 2.5. So I put a 2.5 right there. And what are we trying to solve for? PS. PS is this segment. Instead of calling it PS, let's just call it like X or something. Makes it a little bit easier, doesn't it? Okay. So now take a look. Doesn't this look exactly like what we just talked about? Yeah. All right, so let's see how we're going to set this up. We can set it up several different ways. We saw that we had 4 different ways we could set it up, and all 4 of those would give you the same answer. So we're trying to solve for this one right here. So what would we do to solve for X? Let's compare X to something. X to what? You got 2 choices. To 2.5? Okay, so let's go X to 2.5. Now, I had 2 choices there. I could have gone X to 2.5, or what's my other choice? X to 7.5. All depends on how you do the first one, on what the second one's going to be. So if I go X to 2.5, what am I going to have to do over here? That's right, 7.5 to 3. So 7.5 to 3. And now what do? Cross multiply. I did this for my other class, and they're like, don't, you're going to mess me up. But I just want to show you. What is this 2.5 doing to the x? It's just dividing, isn't it? Since x is already on the top, how can I get rid of something that's being divided? Just multiply. So I could just multiply by 2.5 and I'd be done. All right? But the other class is like, oh, just stick with cross multiply. You're confusing us. So I'll just stick with cross multiply. So 3x equals, and then watch, I'm just going to write it out. I'm not going to do it in a calculator just yet. I'm going to put it into a calculator, but I'll do it all in one shot, okay? You with me on that? There's my cross multiply. How do I get x by itself?
Divide by 3.
Divide by 3. So divide this side by 3, divide this side by 3. So x equals, now we take this and throw it into a calculator. Watch this. Boom.
Ooh.
Is that fancy or what? I just
Wait, how do you do that?
I've used it for my other class, my honors class. I've used it quite a bit, so I'm used to seeing it. But I use it in my 4th period class today, which is a CP, and they reacted the same way that you did. So yes, I downloaded it. I didn't make it myself. So here we go. It's 7.5 times 2.5 times 2.5. And then I always like to hit equals. I don't think you have to, but I always like to. And then you take that and divide it by 3. Okay? And there you go, 6.25. 6.25. There you go. That's all you have to do for something like that. That's not too hard, is it? Nah, it's pretty easy. All right, let's do another type of thing. We're going to talk about a triangle again, and we're going to talk about a parallel side, but I want to make that parallel side. If you remembered what I said earlier, I said that side right here, or this length right here, everybody listening? I didn't say it was in the middle or anything, did I?
No.
I just said it's parallel to this. So, I mean, this side really could have been way down here if I wanted to, couldn't it?
Yeah.
Okay? It could have been way down here, or it could have been way up here. Okay? Just because it looked like it was close to the middle doesn't mean it needs to be. But on this next thing we're going to do, we're actually going to take this thing, and we are going to put it right in the middle. So let's take a look at that. All right, we got a nice little triangle right here. But what I'm going to do is I'm going to take 2 of the sides. I don't care. I could take this side or this side. Let's label it. We'll use the same letters that the book does, just to stay consistent. Look, I could take these 2 sides, or these 2, or these 2. I just happen to take FH and GH. All right. What I'm going to do is I'm going to find the midpoint, and I'm going to put a midpoint on these 2 sides right here. Okay, this side and this side. All right. So where do you think the midpoint's going to be? Let's go different color here. Actually, do this. Let's make it yellow. Stands out a little bit better. Okay, so the midpoint would be about right there, wouldn't it? All right. Oh, it made it blue again. That's okay. Who cares? Oops. Okay, this right here. Let's see. It would be right in here somewhere, I guess. Now watch what happens. Watch what I'm going to do. Yellow. What I'm going to do is I'm going to connect those 2 midpoints to each other. All right. So see this yellow? And look at FG. What is, and they named this, what did they name this? JK. Just kidding. So this side right here and this side right here, what looks, just eyeballing it, what do you think might be true about those two? It looks like they're parallel, not perpendicular. Perpendicular is form a right angle. Okay, but it looks like they're parallel to each other, doesn't it? Okay, and they absolutely are. This is another theorem, right? Yeah, they call it the triangle mid-segment theorem, because what we just did right there, we found the midpoint here, didn't we? That means that these two segments are equal. We found the midpoint right here, which means these two are equal. Does that mean necessarily that this one equals this one? No. All right, but these two right here equal each other, and these two right here equal each other. So that thing is called the mid-segment. Mid-segment. Okay, mid meaning where? It's in the middle. Okay, so we took two sides, found the midpoints, the midpoint, the middle, and we connected the two midpoints to each other, and we got this thing called the mid-segment. Now, there's two things that are true about the mid-segment. One, you kind of eyeballed and you probably figured out yourself. What do you think? JK was what? You guys just told me about 2 seconds ago.
Parallel to FG.
It's parallel to FG, right? So it's parallel to FG. So that's one thing that's true about the mid-segment, that this is going to be parallel to this. So let's mark that. All right, so they're parallel to each other. Now there's a second thing. Now you may not just be able to look at it and eyeball it to figure that out. Brett, get your head up. Blake, get your head up. Get your head up. Sit up straight. Up straight. There you go. That's what I mean. Jonathan, get your head up. That's just disrespectful. It really is. Okay? You know how you kids all the time, don't diss me, don't disrespect me. Well, that's what you're doing to me. You're dissing me, all right? And I don't like it. Here we go. There's something else that's true about this mid-segment in this FG. Anybody want to just take a guess? It's parallel to it. We know that. What about the length of it? Are they equal to each other in length? No, because the further up you go, it's going to be smaller and smaller. But it's right in the middle, so what do you think? It's exactly right. This is exactly half of FG. So watch this. JK, the length of JK, is equal to half of this whole thing, FG. And that's pretty easy. So for instance, what if I told you that FG was 10? What would JK be equal to? It'd be 5. It's as simple as that. Pretty easy, isn't it? What if I told you that that JK was 3? What was FG? It'd be 6, okay? So this opposite side, the parallel side, is double this shorter one that's inside the triangle. Everybody see that? All right. With that said, let's do an example and see if you really understand what's going on here. So let's find the midpoint of these sides. Let's find the midpoint of all 3 sides, to tell you the truth. So where do you think it is? About right there? That's mid-segment of that one. Okay, and that would be right there. That's pretty easy to find. Right there. And let's find the midpoint of this segment. That would be, come across there, right there. Okay? So watch what I'm going to do. Let's change colors here. Let's drop this from here to here. And let's take this and put it over to here. It's not exactly where it should be, but that's close enough. Alright? And they label this one Y down the bottom. This is X, and this is Z. Alright, here's what they tell you. They give you some information about some lengths and stuff. They say that XY is 7, so I'll put a 7 there. They say this angle right in here is 124 degrees. And they say the whole bottom of this thing is 13. Okay? Alright, here's what they ask you. They ask you for XZ equals, and they ask you for ST, and they ask you for angle RYX. So let's think a little bit, okay? The more you think, the more you tend to stay awake. The reason you guys have your heads down is because you're not thinking ahead. You're just letting me tell you everything, all right? And that gets boring. What you have to do is you got to think ahead. Let your mind start working. Try to figure out what's going on. So let's take a look. XZ. Let's find where XZ is. It's this one across from here, okay? Well, look, I went from a midpoint to another midpoint, didn't I? So guess what xz is to this side right here? It's a what? What's the name of it? What's the name of the segment? It's called a mid-segment. Very good. So it's a mid-segment. So there's a couple things we know about the mid-segment. First of all, it's parallel to that opposite side. And what's the second thing we learned? That this is half of the whole length. So if this is 13, and I wanted to find xz, you know how I always write show your work on your paper? Sometimes you can do stuff in your head. And I realize that. I realize you can take half of 13 in your head, but this is what I want you to show when I say show your work. Just write 13 over 2. What is 13 over 2?
6.5.
It's 6.5 or 6.5. Okay, that's what I mean by showing your work. It's not necessarily a lot of stuff, is it? But you showed me how you got 6.5, and that's what it is right there. It's 6.5. That was easy. You could leave it 13 over 2 if you want, but since it's lengths of a triangle, lengths of segments, a lot of time, most of the time you would write it 6.5 or 6.5, okay? But technically 13 over 2 is the same thing, and I would accept that, yes. All right, what about ST? Look at ST. ST is this whole segment right here. Well, what do you see that relates to this ST? XY. Yeah, look. XY is a mid-segment because why? It goes from a midpoint to a midpoint. So this is a mid-segment. So what's the opposite side of this mid-segment? XY. ST. So if this is 7, what's ST? It's 14. Again, let's show the work. What's all the work you had to do?
14 times or 7 times.
Just 2 times 7, right? 7 times 2. And that's 14. That's showing your work. It's showing me how you got that answer to be 14. Right? I know you could do that in your head. But that's how we show how you got the answer. All right, let's do this one. Angle RYX. Here's R, here's Y, and here's X. So we're looking for this angle right here.
124.
How do you know it's 124? Because it looks like it. Is that a good answer?
No.
No, it's not right. You can't just go by what it looks like.
You tricked you.
The 124 is right, but the reasoning is not correct. Not because it looks like it. They're alternate interior angles. That's right. You need reasons to back up what you have to say. Right? So look what I have. And it's like, well, what's alternate interior? Look, I got parallel lines, don't I?
Yeah.
Because it's a mid-segment. Connects the midpoints. It's a mid-segment, so it's parallel. So this is parallel to this. Watch, if I wrote it out like that, those are your two parallel lines. That's your transversal. Look, that's your 124, and they're asking for this angle right here. Do you see it now? This is 124. This is going to be 124. There's really no work to show for that because you just look and you say, oh, yeah, that's right. They're alternate interior angles, so that has to be 124 as well. Do you agree? All right. And that's it. That's the three things that they ask for. It's not so bad at all, is it?
Yeah.
All right. We got one more thing to do. All right, here we go. I got 3 lines. They're not just any old 3 lines. What do you think's true about those 3 blue lines? They are parallel to each other because I said they are. All right, and that's the way I drew them. So they are parallel to each other. But look what happens. I don't necessarily have a triangle right here, but I do have 3 parallel lines, and I got a couple transversals. So if you look at this, I'm going to call this little segment from here to here, I'm going to call that A. And from here to here, where they intersect, I'll call that B. Is that all right? Then what do you think I'm going to call this? C and D. All right? So this is really, really similar to the first thing that we did today. Let's just do it real quick. And you could probably figure it out. What am I going to compare A to? A to... Okay, I could go A to C. Right, either way. But if I went A to C, how would I compare the other two? B to D. Do you see it? Look, I went from the left to the right, and then I went from what? The left to the right. And so that would be B over D. You could compare another way. You can compare A to what else? To B. So I could go A to B if I wanted to. But if I compared A to B, I'm going from the top one to the bottom one. What would I have to do over here? Right, C to D. Makes a big difference. You can't go D to C. It has to go C to D. If I go top to bottom, this has to go top to bottom. Okay? If I go left to right, this has to go left to right. You can't switch them up. You can't go this is left to right and this one right to left. You can't do that. All right? So it's either one of these would be perfectly acceptable. Doesn't that look very close to what we did at the beginning? But at the beginning, we had sides of a triangle, or segments made of a triangle. This is not a triangle. This is just parallel lines cut by transversals. Okay. Now, eventually, watch. If I scooted that up and I scooted that up, eventually that could become a triangle, couldn't it? All right. So you can kind of see where it comes from. All right. That's pretty easy. Let's change that up just a little bit, and then we'll do an example with that. This picture looks really close to what we just did. But I scooted this one down a little bit, and I scooted it to that particular place because, watch this. I wanted this segment and this segment to be equal to each other. Okay? Watch, I'll still call this A and B, and I'll still call this C and D. But these two are equal to each other. Just kind of off the top of your head, what do you think might be true about C and D? They're going to be equal to each other as well. Okay, let me show you why. Because if I compared A to B, I said they're equal to each other, right? Stick a number in there. Let's say 5. Let's say this is 5. Then this would be what? 5. All right? Let's not be silly, okay? I know you're just doing that to be funny. It's not really that funny. Look, 5 to 5. What's the ratio? What's the scale factor of this side to this side? It's 1 to 1, isn't it? Okay? Now watch. Remember I said A to B is the same as what? C to D? So what's the scale factor of C to D? It's 1 to 1 as well. So what must be true about C and D? They're equal to each other. Does that mean C is equal to A, though? No. It means just C and D are equal to each other. I mean, this could be 7. What would D be if this was 7? That would be 7 as well. Does that make sense? So if they just tell you one side, or this segment and this segment are equal, they didn't tell you these were equal to each other, but they told you these two are equal, parallel lines, that automatically means that these two other segments are going to be equal to each other. We got it? All right. I ran out of time to do the example, but it's on page 488. And if you want to look on 4th period geometry, I actually do that example. So you can look there. I was planning on giving you a worksheet, but I ran out of time in my other class to make copies, and I didn't have time this morning. So that doesn't mean you get out of anything. We're doing this, page 489. I'm sorry. It's supposed to be page 489 and 490, and we are doing 10 to 25. Okay, it's section 7-4.
That's overdose.
All of them. So it's 10 to 25, page section 7-4.